Hey everyone, welcome back to Python से AI तक. I hope you are doing great and are excited to begin your generative AI journey. In this generative AI bootcamp, we will learn everything step by step, starting from the basic and gradually moving toward advanced topics. So, today is day one, and our goal is not to build AI models yet. Our goal is to understand the strong foundation behind generative AI. So let's quickly look at what we will learn in today's session. We will begin by understanding what artificial intelligence actually is. Then we will see the relationship between artificial intelligence, machine learning, deep learning, and generative AI. After that, we will learn the difference between rule based AI and pattern based AI. We will also explore the different types of machine learning, understand regression and classification, see how recommendation system works, then learn the complete machine learning life cycle, and finally understand what generative AI is really. By the end of topic, you will have a clear roadmap of where we are going in this entire course. So without wasting any more time, open your Jupyter notebook and let's begin our first step into the world of generative AI. Let's get started. Now let's begin with our first and most important concept. What is artificial intelligence? So, artificial intelligence or AI is a branch of computer science that focuses on creating machine capable of performing tasks that normally require human intelligence. But what does human intelligence actually means? As human, we can learn from our experiences, solve problems, understand language, recognize people and objects, make predictions, and take decisions. The goal of AI is to develop systems that can perform similar tasks intelligently. Now let's look at some of these tasks. The first one is learning from data. Instead of memorizing everything, AI can study large amount of data and identify useful patterns. The second is re- reasoning and problem solving. AI can analyze different situations and suggest the best possible solution based on the information it has. The third is understanding human language. This is known as natural language processing or NLP. It allows AI system like ChatGPT to understand our question and generate meaningful responses. So next is recognizing image and object. For example, face unlock on your smartphone can recognize your face and unlock your device securely. AI can also make predictions. For example, it can predict tomorrow's weather, estimate house prices, or even detect the possibility of certain diseases using medical data. Finally, AI supports decision making. Many businesses use AI to analyze large amounts of information and help people make faster and smarter decisions. Now, let's connect these concepts with real life examples. When Google Maps suggests the fastest route, AI is analyzing traffic condition in real time. Face Unlock uses AI to recognize your face. Siri and Alexa use AI to understand your voice commands. Then Netflix recommended movies based on your watching history. Amazon suggests product according to your interest. and previous purchases. And ChatGPT can answer questions, explain concept, and even generate code using artificial intelligence. So the most important thing to remember from this slide is this: artificial intelligence is all about building smart systems that can learn, reason, understand information, and make intelligent decisions just like humans do in many everyday situations. Now that we understand what artificial intelligence is, let's see how machine learning, deep learning, and generative AI fit into the bigger picture. Now that we understand what intelligence is, let's see how different AI technologies are connected. Many beginners think artificial intelligence, machine learning, deep learning, and generative AI are all the same, but there's not. They are actually part of a hierarchy. At the top, we have artificial intelligence, also known as AI. Artificial intelligence is the largest field. It includes every technology that enables machine to perform tasks requiring human intelligence. Inside artificial intelligence come machine learning. Machine learning is a subset of AI. Instead of following fixed rules, machine learning allows computers to learn from data and improve through experiences. Inside machine learning comes deep learning. Deep learning is a specialized branch of machine learning that uses artificial neural networks. It is designed to solve more complex problems such as recognition, speech recognition, and language understanding. Inside deep learning comes generative AI. Generative AI focuses on creating new content rather than only analyzing existing data. It can generate text, images, videos, music, and ever computer code. And finally, inside generative AI, we have large language models, commonly called LLM. Large language models are trained on massive amounts of text data and are designed to understand and generate human like language. Some popular examples are ChatGPT, Gemini, Cloud, and Llama. Now let's quickly remember this hierarchy. Every large language model belongs to generative AI. Generative AI belongs to deep learning. Deep learning belongs to machine learning, and machine learning belongs to artificial intelligence. A simple trick to remember this is to think from the smallest to the biggest. In the next section, we will learn how artificial intelligence actually works by understanding rule based AI and pattern based AI. Now, let's understand our first approach to artificial intelligence called rule based AI. As the name suggests, rule based AI works by following predefined rules or instructions created by humans. In simple words, the computer doesn't make its own decision, right? It only follows the rules that we have already written. One important thing to remember is that rule based AI does not learn from experience. If we don't write a rule for a particular situation, the system doesn't know what to do. Now let's look at its main characteristics. First, the rules are written by humans. Second, it follows fixed logic. Third, if we give the same input again and again, it will always produce the same output. Since it doesn't learn from new data, there is no learning capability. That's also why rule based AI is easy to understand, easy to implement for a simple task. Let's look at a simple example. Suppose we create a rule that says y equals to multiply by x. If the value of x is 5, then the value of y becomes 10. The computer simply applies the formula and gives us the answer. It doesn't think about a different solution or try to improve this result. It only follows the rule exactly as we define it. We use rule based AI. In many everyday applications, a calculator always follow mathematical rules. An ATM menu follow predefined option. Traffic signal timers work according to fixed timings. Even login authentication checks usernames and passwords using predefined rules. So, the key point to remember is this: rule based AI works well when the rules are clear, simple, and already known. But what happens when the rules are too complex to write? That's where pattern based AI comes into the picture. And we will understand that in the next section. Let's understand this small example. Here we have created a variable called x and assigned the value 5. Next we created another variable called y and apply the formula to multiply by x. Finally, we printed both the input and output. The result is 10. Just execute it. Because the computer simply followed the rule we gave it. If we change the value of x to 8, the output becomes 16. So let's check. See, if we change x to 20, the output becomes 40. Notice that the computer isn't learning anything. It isn't making its own decision, right? It's only following the predefined rule. This is exactly how rule based AI works. Now let's move to the second approach of artificial intelligence called pattern based AI. Unlike rule based AI, pattern based AI does not depend on predefined rule. Instead, it learns directly from data rather than telling the computer every single instruction. We provide it with many examples and the module automatically discovers pattern. So let's look at its characteristics. The first is that it learns from data. The more quality data we provide, the better the model can understand pattern. The second characteristic is that it improves with experience. As it is trained with more data, its performance become better over time. Another important is that it recognize hidden patterns. Sometimes these patterns are difficult for humans to notice, but the model can identify them by analyzing large amounts of data. Pattern based AI is also capable of solving complex problems that cannot be solved using simple predefined rules. That's why it is widely used in machine learning and deep learning. Now let's understand the example shown here. Imagine we want a computer to recognize a cat. Instead of writing hundreds or thousands of rules describing every possible cat, we simply show the model thousands of cat images. Some cats may be white, some may be black, some may have long fur, while others have short fur. By observing many examples, the model gradually learns the common patterns that identify a cat. In another words, the model learns what makes a cat a cat. So the key point to remember is this: pattern based AI learns from data, identifies patterns, improves with experiences, and is suitable for solving complex real world problems. Now that we have understood pattern based AI, let's move to one of the most important concepts in artificial intelligence: machine learning. Machine learning, also known as ML, is a subset of artificial intelligence. In simple words, it is one branch of AI that enables computers to learn from data instead of following fixed rules. Unlike rule based AI, where humans write every instruction, machine learning learns by observing examples and identify patterns. That's why we often say machine learning teaches computers to learn from data instead of being programmed with every rule. Now you may wonder, why do we even need machine learning? The reason is simple. Many real world problems are too complex to solve using fixed rules. Let's look at a few examples. Face recognition is one example. Every person face is different, so writing rules for every face is almost impossible. Voice assistant like Siri and Alexa understand our voice using machine learning. Then email spam detection learns to identify unwanted email automatically. Then weather prediction analyzes huge amount of weather data to forecast future condition. Then medical diagnosis help doctor detect disease by analyzing patient data. Then product recommendation system suggests products based on our interest and previous activities. All these applications use machine learning because they learn patterns from data instead of depending on predefined rules. Finally, let's quickly revise the key point. Machine learning learns from data, improves with experience, it recognizes a hidden pattern, it makes prediction, and it supports better decision making. So remember one simple definition: machine learning is a branch of artificial intelligence that enable computers to learn from data and improve their performance through experience. Now that we understand what machine learning is, the next question is, how does a machine learning model actually learn? The answer is that machine learning is mainly divided into three different learning approaches. Each approach is designed to solve different types of problem. Let's look at them one by one. The first type is supervised learning. Here the model learns using labeled data. So this means both the input and the correct output are already known. A common example is like email spam detection, where emails are already labeled as spam or not spam during training. The second type is unsupervised learning. In this approach, the model learns using unlabeled data. Since there are no predefined answer, the model discovers hidden patterns and relationships on its own. A popular example is like customer segmentation, where business group customers based on similar behavior. The third type is reinforcement learning. Here, the model learns through trial and error. It receives a reward when it makes the correct decision and penalties when it makes a mistake. Over time, the model learns the best possible strategy. Some common examples include self driving cars, chess AI, and robotics. In the next few sections, we will understand each of these three learning approaches in much more detail. So, first type of machine learning called supervised learning. So, supervised learning is a learning approach where the model is trained using labeled data. But what does labeled data mean? It means the training data already contains both the input and the correct output. In other words, the model is learning from example where the correct answer are already known. So let's understand this with the example shown on the screen. Suppose we have a collection of emails. Some emails are already labeled as spam, like congratulations, you won a prize. This type of mail is like a spam, while other are labeled as not spam. The model study this example and learns the patterns that genuine ones. After the training is complete, it can classify new emails that it has never seen before. Now let's look at some real life applications of supervised learning. It is widely used for email spam, um, like spam detection. It helps predict house prices based on different features. It can predict student results by analyzing previous academic data. In healthcare, it supports medical diagnosis by learning from patient record. Bank also use supervised learning for loan approval by analyzing historical customer data. So now let's quickly revise its key characteristics. Supervised learning uses label data. It learns, for example, it provides high accuracy when the training data is of good quality, and it is mainly used for prediction and classification tasks. Move to second, unsupervised learning. Unlike supervised learning, this approach uses unlabeled data. This means the model receives only the input data, but it does not know the correct answer. Instead of being told what to look for, the model explores the data on its own. It analyzes the information and discovers hidden patterns, similarities, and relationships automatically. Now let's look at its characteristics. First, it uses unlabeled data, then hidden patterns that may not be obvious at first. Third, it automatically create group of similar data. And finally, there is no teacher or predefined answer to guide the learning process. It is used in basket analysis to understand which products are frequently purchased together. Banks use it to detect unusual transaction that may indicate fraud. It also helps analyze social networks by identifying communities with similar interest. In some recommendation system, it helps group user with similar behavior. So let's understand the example shown on the screen. Imagine an online shopping website with thousands of customers. The model studies each customer purchasing behavior without anyone labeling the customers. It automatically group people with similar shopping habit. This help business understand their customers and provide better services. So remember this simple definition. Unsupervised learning is a machine learning techniques where the model learns from unlabeled data and discover hidden patterns without predefined answer. Now let's move to the third and final type of machine learning called reinforcement. So reinforcement learning works through trial and error. Instead of learning from labeled or unlabeled data, the model learns by interacting with its environment. Whenever the model makes a correct decision, it receives a reward. If it makes a wrong decision, it receives a penalty. Using this feedback, the model gradually improves its performance. The main objective is to maximize rewards while minimizing mistakes over time. Now let's look at its key. So reinforcement learning is based on trial and error. It follows a reward and penalty system. It continuously improves as it gains more experience, and it learns by interacting with its environment instead of relying on predefined answer. Now let's explore some real life applications like self-driving cars, uh, reinforcement learning to make better driving decision. So self-driving cars, and second is chess playing AI learns the best moves by playing thousands of games. Then robots use this approach to improve their movement and complete tasks efficiently. Game playing AI learns strategies to achieve higher score. Then warehouse automation system also use reinforcement learning to optimize routes and improve efficiency. So remember this example. Now that we have learned the three type of machine learning, let's understand two important terms that you have here several times today: label data and unlabeled data. Let's start with label data. Label data contain two things: the input data and the correct output, which is also called the label. For example, if we show the model an image of a cat and write cat below it, the model already know the correct answer. Similarly, if we show an image of a dog and label it as dog, the model learns from this example. This type of data is mainly used in supervised learning because the correct answer are already available during training. Now let's move to unlabeled data. So unlabeled data, we only have the input data. There are no label or predefined answer. For example, um, imagine a folder containing thousands of animal images without any name. The model doesn't know which image is a cat or a dog. It studies the images, finds similarities, and discovers patterns on its own. This type of data is mainly used in unsupervised learning. So the easiest way to remember this is, now let's understand two important types of prediction problem in supervised learning, that is regression and classification. So regression is used when the output is a continuous numerical value. In simple words, whenever we want the model to predict a number, we use regression. Some common examples are temperature prediction, rainfall prediction, and house price prediction, and stock price prediction. As you can see, the output are always numerical value. Now let's move to classification. Classification is used when the model predict categories or classes instead of number. For example, determining whether an email is spam or not, identify whether a product review is positive or negative, detecting whether a disease is present or not, or classifying a person as male or female. Here, the output belongs to a specific category rather than a numerical value. Now, let's compare both approaches. Regression predicts number, while classification predicts categories. Regression produces continuous outputs, where as classification produces discrete outputs. A simple example of regression is house price prediction, and a common example of classification is example is like email spam detection. Clustering is an unsupervised learning technique. Its main purpose is to group similar data points together without using label. In other words, the computer studies the data, finds similarities, and automatically create group. Now let's look at some popular clustering algorithm. These include k-means clustering, DB-scan, and hierarchical clustering. At this stage, you don't need to understand how these algorithms work. We will learn each of them in details later in the course. Now let's look at some real application. Clustering is widely used for customer segmentation, where business group customers based on similar behavior. It is also used in weather analysis to identify weather patterns. In medical research, it helps group patients with similar characteristics. Social media platforms use clustering to identify users with similar interest. Then it is also useful for understanding shopping behavior. Now let's understand the example shown on the screen. Imagine an online shopping website with thousands of customers. The machine learning model studies each customer buying habits. Some customers mostly buy electronics. Some prefer clothes. Others frequently purchase book. Without any human creating this group, the model automatically identifies similar customer and places them into different groups. This is exactly what clustering does. It groups similar data together by discovering hidden patterns automatically. Now let's understand recommendation system. So recommendation system are designed to help user discover product, movies, music, or other content they are likely to enjoy. We use recommendation system almost every day, even if we don't notice them. There are three main type of recommendation system. Let's understand each one. The first type is user based recommendation, also known as collaborative filtering. In this approach, recommendations are based on users who have similar interests or preferences. For example, if two users like similar movies and one of them watches a new movie, the system may recommend that movie to the other user as well. A popular example of this is Netflix. The second type is content based recommendation. Here, recommendations are based on the future of product and the user previous preferences. Here, recommendations are based on the feature of a product and the user's previous preferences. For example, if you search for purchase a smartphone, Amazon may recommend other smartphones with similar feature. Likewise, the third type is hybrid recommendation. As the name suggests, it combines both user based and content based method. By using both approaches together, the system provides more accurate and personalized recommendation. Many popular platforms such as Netflix, Amazon, and Spotify, YouTube use hybrid recommendation system to improve the user experience. So remember this simple summary. Now let's understand the machine learning life cycle. Many people think machine learning is only about training a model, but in reality, building a machine learning model is a complete process. It starts with collecting data and ends with deploying the model into a real world application. Let's go through each step one by one. The first step is data collection. In this stage, we collect relevant data from different sources such as like customer data, images, text file, sensor data or business records. The goal is to collect high quality data because the quality of the data directly affects the quality of the model. The second step is data analysis. Here we study the collected data carefully. We check for missing values, then duplicate records, outliers, and understand how the data is distributed. The goal is to understand the data set before using it. Third step is data preparation. This is where we prepare the data for training. Tasks such as cleaning the data, encoding categorical value, feature scaling, and splitting the data into training and testing set are performed. The goal is to convert raw data into clean and usable data. The fourth step is model building. In this stage, we choose a suitable machine learning algorithm based on the problem we want to solve. Some common algorithms include linear regression, decision tree, random forest, and neural networks. And the goal is to train the machine learning model using the prepared data. The fifth step is model evaluation. After training the model, we need to measure how well it performs. Common evaluation metrics include accuracy, precision, recall, FN score, and mean squared error. The goal is to evaluate the model's performance before using it in real application. The final step is deployment. Once the model performs well, it is deployed into real world application like include banking system, healthcare application, chatbots recommendation system, and mobile app. The goal is to make the trained model available for user. And finally, let's quickly revise the complete machine learning lifecycle. It starts with data collection, then comes data analysis, after that data preparation, next is model building, then model evaluation, and finally deployment. This is the complete workflow followed in typical machine learning project. Now we have reached the most exciting topic of today's session, generative AI. So what is generative AI? Generative AI is a branch of artificial intelligence that create new content instead of only analyzing existing data. Unlike traditional AI, which mainly focuses on prediction, classification, or analysis, generative AI can produce completely new content based on the instruction or prompts we provide. Let's look at what it can generate. So, it can generate text such as articles, emails, stories, or answer to question. It can generate images for simple text description. It can create audio including speech and music. It can even generate videos, and it can also write computer code, making software deployment, uh, making software development faster and more efficient. Now let's look at some popular example. ChatGPT is widely used for text generation. Dolly can generate images from text prompts. Sora is capable for generating realistic videos. GitHub Copilot helps developers by generating code and coding suggestion. And finally, let's look at some of the most popular large language models, also known as LLMs. GPT is developed by OpenAI. Gemini is developed by Google. Cloud is uh, sorry, Cloud is developed by Anthropic, and Llama is developed by Meta. Throughout this course, we will explore these models and how to use them to build practical AI application. And with that, we have successfully completed day one of our generative AI bootcamp. Today, we built a strong foundation by understanding artificial intelligence, machine learning, deep learning, rule based AI, pattern based AI, the different types of machine learning, regression, classification, clustering, recommendation system, the machine learning lifecycle, and finally, an introduction to generative AI. Don't worry if everything doesn't feel perfect yet. Learning AI is a journey, and every expert once started with the basic. Before our next class, I encourage you to revise today's note once and try to understand each concept in your own words. A strong foundation will make the upcoming topics much easier to learn. In our next session, We will dive deeper into generative AI and start exploring the techniques that power modern AI applications. If you found this video helpful, please give it a thumbs up, share it with your friends who want to learn AI, and subscribe to Python's AI Tech so you don't miss the upcoming lessons. Also, let me know in the comment which topic from today's class did you enjoy the most. Thank you so much for learning with me.